The last lesson in this chapter is the conjugate root theorem. So it's kind of saying, okay, we have pairs of these, like I know the roots, so now I can make an equation. I can go backwards from what we've been doing. So things that will have pairs are roots, and by that I mean square roots, and imaginaries. And remember that imaginary is I. Things that will not have pairs necessarily will be just plain numbers. Okay, so we're reading this. So first we're going to look at what has roots and what their conjugate roots are. So a quintic polynomial, that's something that's important to begin with. A quintic polynomial. What does quintic mean? That means there's going to be 5 roots because it's quintic. Has zeros at 2i and -3 plus root 5 and 1. Find the other zeros and write an equation from that. Okay, so first, how many roots should there be? Well, there should be 5 because it's quintic. So the roots that you're given are 2i, -3 plus root 5, and 1. All right, so what you're doing is you're finding the conjugate roots of these. So we said that imaginaries have opposites. So remember when you're doing imaginaries, you get plus or minus. So it's going to have -2i. Same thing goes for square roots, but what changes is the sign in the middle. And then numbers don't necessarily have one, so that would be none. It's probably better to put none instead of x because you might think it's a variable instead. Okay, so let's look at the next one. This one says a cubic polynomial. So cubic tells me that there's going to be 3 roots. Has one at 4 and root 5. So you're given 4, you're given root 5. So which ones have pairs that go with them? Well, numbers don't, so that would be none. And square roots do, so this would be the plus or minus of it. We need minus root 5. So let's talk about how we make an equation for this. So we're going backwards. We know the roots. So we know that we're going to have x minus 4 because it's the opposite. Because if you set this equal to 0, that's what would give you the 4. That's why it has to be the opposite of that. So we have x minus 4. Then we do the opposite of our roots. We would have x minus root 5. And then our other one is to do x plus root 5. Okay, so you're going to FOIL these together. My suggestion to you is definitely to do your square roots together first. If you don't do the square roots together first, you're going to get a big jumbled mess. So when I combine these, I get x squared minus root 5x plus root 5x minus the square root of 25. Okay, so the negative and the positive go away. So now I know the square root of 25 is 5. So now I drop down my x minus 4, and now I have x squared minus 5. And I'm going to FOIL these together to get x to the third minus 4x squared minus 5x and plus 20. And that's your final answer to what this equation is. So we could do our putting it all together that we've been doing to go backwards with synthetic division and solving from this to get back to that. Okay, so we're just going the opposite of what we've been doing. So let's do one more of these. So we have a cubic polynomial with -2i and 5. Okay, so what that means is we're going to have the -2i and the positive 2i. So we're doing the opposites of those. So when we set up this problem, we're doing x plus 2i, x minus 2i, and x plus 5. Opposite is super important. Okay, so this one went here, this one goes here. All right, so again, as we did with the square roots, I would put your imaginaries together first because that's going to give me x squared plus 2ix minus 2ix minus 4i squared. Well, I know that these will go away, and I know that this is really -4 times -1. So what I'm left with is x squared plus 4 and x plus 5. And now I can FOIL that again and get x to the third plus 5x squared plus 4x plus 20. And again, we could do all of our synthetic division that we've been doing, and that would take us back to the original roots. But now we have the roots, and we're solving for the equation of those.